In this video tutorial, we are going through the steps to conduct a continuous gauge R&R in Minitab. So you need to measure the time it takes to complete various types of requests received from the customer. For each request, a case is opened into a database. So the study that you will conduct is the following. You select 10 different cases, and each case relates to a specific type of request. You ask 3 subject matter experts in your team to calculate the end-to-end time for each case. They will have to calculate it looking at the various cycle times for each status of the case. And the case can be on hold, on audit, in process, etc. 2 days later, you ask the same subject matter experts in your team to recalculate the end-to-end time for each case. Now, the overall variation that we will see will come from the part-to-part variation, which is the difference due to the fact that each case relates to a specific type, so the end-to-end time for each specific type will be different. But we can have as well the variation due to the measurement system variation. And in this case, we can have an issue with the repeatability, which is the variation observed when the same item is measured multiple times by the same person. And we can have as well a variation due to operator, which is the reproducibility. And the reproducibility is the variation observed when the same item is measured by different people. So after collecting the data, in Minitab you should have a similar table. One column with the SME operator, another column with the trial. So for example, Carol measured the end-to-end time for the 10 different cases, and after 2 days she will recalculate it. So if we scroll down the table, we can see that we have again Carol, but this time for the trial number 2. Then the third column, it's related to the case inspected from 1 to 10, and the column number 4 is the end-to-end time, so the measurement that has been recorded by each operator. Now, let's see how to conduct this Gage R&R in Minitab. We choose Stat, Quality Tools, Gage Study, Gage R&R Study, Crossed. Then we fill in the different sections where the part numbers will be the case inspected, the operators are the SMEs, and the measurement data is the end-to-end time that has been recorded into the table by the operators. The method of analysis will be the X-bar NR for this time. When we click OK, then we can see that we have all the different charts in one window. But we can have the possibility to have each chart in a single window. So let's do it. Let's close this one. We reopen the dialog box. We go into Options and we click on Draw Graphs on Separate Graphs, 1 graph per page. Now we have all the different charts and each of them is in one window. So for ease of interpretation, we are going to click on this button here so that we can see all of them full screen. So let's start with the first one. So the first one is the variance component, which is what percentage of the total variation is from what component. So the best is to have the Gage R&R, this one, very small, and see that the largest component of variation is due to the difference in parts, like this one here. So, in other words, if the first clusters of bars is much higher than the part-to-part, then it means that most of the variation is caused by the measurement system. While in this study we can see that most of the variation is due to the part-to-part, and this is what we wanted to see. However, we can see that we have still an issue with the repeatability. So our measurement system is showing that there is a variation due to the measurement. And in particular, and specifically, we have more issues with the repeatability than the reproducibility, as we can see that the cluster is higher than the reproducibility. So remember that the repeatability is the variation observed when the same item is measured multiple times by the same person, while the reproducibility is the variation observed when the same item is measured by different people. While the part-to-part variation is the variation observed across the different items, and it's not due to the measurement system. Now, the red bars represent the percentage of variation that each component contributes to the total variation, while the green bar represents the percentage study variation. So, the conclusion that we can draw from this chart is that most of the variation comes from the part-to-part, and that the majority of measurement error is caused when the same operator measures the item multiple times. Now, let's evaluate another chart. Let's evaluate the X-bar in our charts to analyze the part-to-part variation and the repeatability of the measurement system. The R chart that we can see at the bottom is used to evaluate the repeatability. So each data point that we can see on the bar represents the range of the appraiser's measurements. If any data point fall outside the control limits, then we know that the appraiser has difficulty to measure the same item in a consistent manner. So we can see here that we have two data points that fall outside the control limits. Usually when we have data points that fall outside the control limits in the R chart, we shouldn't trust the specification limits that we have in the X-bar chart. While the X-bar chart shows the part-to-part variation. Each data point is the mean of the measurements from the various appraisers. So what can we see in this chart? We can see that the chart shows differences among the parts because we have a lot of data points that fall above and below the control limits. What we want to see in this chart is identical patterns between the different appraisers. And this is more or less the situation that we have here. We can see that we have the same pattern for each of them. Now, let's see another graph, the third one. So, according to the measurement by case inspected, we can see which case has the least or the most variation in its measurement. The more tightly clustered the points, the less variation in the measurement. And we can see in this chart that the most tightly clustered points that we have, it's for part number 5 and part number 9. Let's see another graph. So this graph shows the differences among the appraisers. Each box plot contains all the measurements for each appraiser. What we want to see is the same average for the appraisers. And this is the average that is represented here. But looking at the graph, we can see that there is an appraiser that took higher measurements than the others, which is Mark. Maybe it's due to the fact that Mark needs additional training, or maybe he uses another technique. So we know that in order to calculate the end-to-end time, we need to consider the different statuses for the case. So maybe he misinterpreted one status. We can see as well that there is an outlier for David, this data point here. And maybe this is due to the fact that David misinterpreted the value or didn't write correctly the value when he took it. Let's see another graph. This graph shows the case inspected by SME. What we want to see in this chart is the lines on top of one another. meaning that all the appraisers obtain consistently the same results when measuring the same items. So we do not have problem with the repeatability. If the lines do not overlap, then it means that there are differences among the appraisers. So here we can see that they do not overlap perfectly, so we have an issue because there is a difference among the appraisers. So that's all. Thank you for watching.